All right, this is the How Fast Are You Moving Right Now lab. First thing I'm going to do, put a little hand sanitizer on my hands just to make sure any germs that are on my hands don't get on any of the lab equipment. All right, so the purpose of this lab activity is for you to investigate the concept of frame of reference. So the directions. Answer the following questions on the fastest humans can travel. The second part of this lab will be researching how fast we are traveling through the universe. The last part of this lab will be graphing the data. This will require some research. Convert all units to meters per second. So this will require you to convert, when you're looking these up, sometimes they'll give you the measurement in meters, in miles per hour, kilometers per hour. Just find some conversion online to convert them all to meters per second so we can graph them and then compare them. So let's just start off with the first part of this, where we're talking about how fast humans travel on Earth. So the primary method of humans used to travel from place to place is using their bodies to walk. What is the average walking pace of a human in meters per second? So the next question. For thousands of years, the only thing humans could do to travel faster than a walk was to run. Usain Bolt is the fastest runner alive. What is Usain Bolt's top speed in meters per second? All right, next question. Humans eventually developed vehicles to travel faster and farther. The SSC Tuatara is the fastest car in the world. What is the top speed of the SSC Tuatara in meters per second? So the next question. Humans can go even faster with trains. The Shanghai Maglev train, also known as the Shanghai Transrapid, is the fastest train in the world. What is the top speed of the Shanghai Maglev train in meters per second? The next question. Humans took to the skies with planes to get to places even faster. The Lockheed SR-71 Blackbird is the fastest plane in the world. What is the top speed of the Lockheed SR-71 Blackbird in meters per second? The next question. When humans set their eyes on space, the speed that humans could travel greatly increased. The fastest that any human has ever traveled were the 3 astronauts on Apollo 10 on their way to the moon. What was the top speed of Apollo 10 in meters per second? So that's all going to require you to do a little bit of research. Now the next part is talking about how fast Earth is traveling through the universe. So you're standing still in this room. Relative to this room, how fast are you moving? So that one's an easy one. I'm just sitting here, right? Relative to this room, I'm not really moving. This room is in Indianapolis on the planet Earth, which is rotating about its axis. Relative to the Earth's axis, how fast are you moving? So you're going to have to find your latitude. At the equator, the Earth is rotating a lot faster than if you were at the North Pole, where you'd just be going in a circle. So you have to look up the latitude of where you are. And then there are websites that you can plug in that latitude and find the speed at which you're traveling and just convert it to meters per second. The Earth revolves around the sun. Relative to the sun, how fast are you moving? The solar system revolves around the supermassive black hole Sagittarius A star at the center of our galaxy, the Milky Way. Relative to Sagittarius A star, how fast are you moving? The Milky Way is moving toward what is called the Great Attractor 147 million light years away. Relative to the Great Attractor, how fast are you moving? The Milky Way is moving with respect to the cosmic background radiation, or the remnants of the Big Bang. Relative to the cosmic background radiation, how fast are you moving? The maximum speed in the universe is the speed of light in a vacuum. You cannot travel faster than that. What is the speed limit of the universe? So once you do all of that, what you're going to do is you're going to place the results from this lab in a Google Sheets or some graphing program attached to this assignment and copy the charts in the space it provided. So the 3 graphs should be the speed of humans on Earth, speed of Earth in the universe, and the speed of light. And that graphic representation will really show us like the relative speeds. All right, so now those conclusion questions. So this first one, you're going to look at the speed of Earth in the universe graph. What can be said about the speed of humans on Earth when compared to the speed of Earth traveling through space? The next question says, look at the speed of light graph. What can be said about the speed of humans on Earth and the speed of Earth traveling through space when compared to the speed of light? The next question. You have just researched and concluded that you, on Earth, are spinning and traveling through space incredibly fast. Do you feel this motion? Come up with a good scientific claim to describe why or why not. And remember, for a claim to be scientific, there must be a test for something. The next question. In all of the questions where you were researching the speed of Earth through the universe, what did you need in order to answer all of them? So this is tricky. Just look at the phrasing of those questions and what did you need in order to answer all of them? In all of the questions where you were researching the speed of humans on Earth, why do you think a frame of reference didn't need to be established? Why do you think the questions were just as, how fast, what was the top speed of Usain Bolt? Why do you think that when we're talking about people traveling on Earth, we don't establish that frame of reference, but when you're talking about Earth traveling through the universe, there was that frame of reference. And the last question is, there's only one question left to ask. How fast are you moving right now? So last thing I'm going to do is put a little hand sanitizer on my hands just to re-sanitize my hands. And once again, this is the How Fast Are You Moving Right Now lab.